All right. So 2.1 is rates and proportions. So I'm about to write a note to myself. So this part is not for you guys, but the title is for you. Um, 9.2. All right. So I've already done notes on rates and proportions. So I'm going to go to that section. So I was just writing a note for myself. All right. So we're looking at it was 9.2 for that class, but it's 2.1 for you guys. Rates, ratio, and the proportions. This over here. All right. So rates is a comparison or our comparison of two quantities. It can be written as a fraction. So they don't necessarily have to have the same units. An example of that is 135 miles over 6 gallons, or 135 miles every 6 gallons. That divisional bar also is sometimes referred to as per. So whenever you see miles per hour, that's miles over hours. So that's 135 miles per 6 gallons. All right, a unit rate, if they were to ask you about unit rates, a unit rate is a rate in which the denominator is 1. So if I wanted to convert that 135 miles per gallon, per 6 gallons, I would divide 135 by 6. That would be 22.5. And that means I would have 22.5 miles for every 1 gallon, or in other words, 22.5 miles per gallon. So once again, a unit rate is when your denominator is 1. All right. A first example, a dental hygienist earns $1,304 for working a 40-hour week. What is the hygienist's hourly rate of pay? So you want to know how much this person makes per hour. So we know how much this person makes every 40 hours. We want to know how much this person makes per hour, every 1 hour. So you take the dollars over hour relationship, 1304 over 40. Divide those, that'll give you 32.6. So that means you have $32.60 for every 1 hour, or in other words, $32.60 per hour. Next one, which is the more economical price or purchase? An 18-ounce jar of peanut butter priced at $2.69, or a 28-ounce jar of peanut butter priced at $3.99. So you want to know how much per ounce you are paying. So that's cost per ounce, dollars over ounce. The unit that comes first in your phrasing is your numerator. Second one is your denominator. So it's cost per ounce, dollars over ounce. So I take that 269, place it over 18 ounces. And if I want to know how much per ounce, I divide the 18 into 269, and that gives me 0.149. So it's 0.149 for every 1 ounce that you're paying. Do the same for the next relationship. $3.99 divided by 28. And that'll give you 0.143. That left off the 3.143. So since the $3.99 per 28 ounces is shows that we're only going to pay $0.143 per ounce, that is the more economical price, paying the least amount. All right, questions so far? All right, ratios. So the difference between ratios and rates. The ratio is the comparison of two quantities that have the same units. So before they didn't have to have the same unit. In your rates, you could do dollars to ounces. Here, the comparisons that you are making have to have the same unit, have to be written in the same units. All right, so you can write these three different ways. You can use it as a fraction, 2/3, colon, that's 2:3, or use the word 2 to 3. Notice the one that comes first always comes first, no matter what relationship you're using, whether it's a fraction, colon, or the word 2. And the one that comes behind the wording is the one that comes that's behind it, or in the denominator or after the colon. All right. And if I scroll up too fast, feel free to let me know. I'll just scroll back down. It's not a big deal. All right. So next example, a survey revealed that on average, eighth graders watch approximately, APP was me shortening the word approximately, 21 hours of TV each week. Find the ratio as a fraction in simplest form of the number of hours spent watching TV to the total number of hours in a week. All right, so the problem here says find the ratio as a fraction in simplest form of the number of hours spent watching TV. So the thing we have to notice here is that 2 is our marker, the word 2. So whatever comes before 2 is my first number or my top number in my fraction. What comes after 2 is my bottom number. So the number of hours spent watching TV. So we already know that answer is 21. And then the total number of hours in a week. So my top number is 21. Now I need to calculate the total number of hours in a week. So we know there's 24 hours in a day and there's 7 days in a week. So I take 7 multiplied times 24, and that gives me 168 hours. So that will be my bottom number. All right. So place the 21 over the 168 and then reduce. 21 goes to 168 8 times, so you can cancel out the 21 completely, and that will leave me with 1 over 8. So always remember, whenever you're reducing your fractions, if by some chance you don't see the whole 21, you can always start off recognizing that 21 is divisible, or can be broken down 3 times 7. And you can just do them, individually. Maybe divide both by 3, see what happens. Divide both by 7, see what happens, and so on. Questions on that? All right, let's look at the next one. Unit ratio is very similar to unit rate. Unit ratio is when the denominator is equal to 1. Just like a unit rate was when the denominator is equal to 1. Unit ratio is when the denominator is equal to 1 as well. Next example starts off with a chart. We have university, 2 universities: Oregon State University, OSU, University of Oregon, UO. So I just shortened it up. They tell us how many men and women, as far as students that they have, and then the number of faculty. So in OSU, we have 10,018 men, 8,459 women, 1,471 faculty members. And then at Oregon, University of Oregon, 8,849, 9,824, and then 1,364. So then they ask us to calculate the student faculty ratio at OSU. So notice they're talking about OSU, University of Oregon. Information is not necessarily needed for this problem. Then round to the nearest whole number, write using the word 2. So we want to know student faculty ratio. Um, since we're talking about all of students, we need to add together the men and the women, and that's going to be 8,477. Student to faculty, or student dash faculty, however you want to see it. The first part of the relationship is student, so that means as far as your fraction go, or the word 2, student should be first or in the numerator, faculty would be down bottom. So we want to know how many students would be in campus or on campus or registered for campus compared to one faculty member. So we would go ahead and divide that 1471 into that 18,477. That gives me 12.56. So they tell us first to round to the nearest whole number. So that's 13 over 1. And also write it using the word 2. So it's a 13 to 1 ratio. So for every one faculty member, there are 13 students. Questions? Any questions before we get to proportions? All right. Proportions, a statement that says that two ratios or rates are equal. So in other words, two fractions basically are equal. 2/3 equal to 12/18 is an example of a proportion. All right. The way we will be able to verify our proportional relationship is to use the cross products. And it just says that if I have two fractions equal to each other, AB equal to CD, I should be able to cross multiply, in which if I take the denominators up to its opposite numerator and multiply, then I should get two numbers that are equal to each other if we actually have a proportion. So I would take D up to A, take B up to C, and that means AD would be equal to BC. So if I take that 2/3 equal to 12/18, I would take the 18 times 2, then do 3 times 12. 2 times 18 is 36. 3 times 12 is also 36. And so that just verifies that we have a proportion. All right. So we can use that relationship to solve. So if I have 8/5 equal to n/6, and I want to know what is that missing piece, I will cross multiply, take my 6 up to 8, 5 up to the n. So on the left side, I have 6 times 8. On the right side, I have 5 times n. Then to solve for n, divide both sides by 5. 5 cancels on the right, and on the left, 48/5. And my math lab will let you know which one they want.
Can you scroll up a little bit because I can't see where you're multiplying?
Say again?
I can't see the bottom of your screen where you just did the divide each by 5.
Oh, so let me ask you this. So right there, you can't see the screen?
No, when it's like that, I can't see the 5s. Right now, I
So
can see them.
that's weird. Okay. All right. Now, anybody else can chime in. Could you guys let me? I'm just doing a test. All this stuff I need to know. When it's like this, can you guys see the 5? I know she said she couldn't. Anybody else can just unmute. Can you see the 5s?
I can.
Yeah, I can see
Okay.
it.
Okay. So some people can, some people can't. Okay.
Do I need to make my screen bigger? Let me figure it out.
Okay.
Yeah, I can see.
Okay. All right. So I'm just, testing this stuff out. This is new for everybody. So I need to know the limitations and all the good stuff like that. So yeah, if you ever have any type of issue like that, feel free to chime in, let me know. Because that's something I need to consider. Even if 99 out of the 100 can see it, if one person can't, then that's something I need to, try to adjust for to make sure that we're good. So, so yeah, divide both sides by 5, and we have 48/5 or 9.6. All right, so let's look at the word problem. So if you travel 290 miles in your car on 15 gallons of gas, how far can you travel on 12 gallons of gas under similar driving conditions? So you should be looking to set up a proportion. Whatever you set up, you want to make sure you are consistent in your setup. So in other words, if I do miles over gallon for one fraction or one ratio, I want to make sure I say miles over gallon for the other one. I should say rates. So I decided to do miles over gallon. You can do gallons over mile. You can even play with it a little further and set up other relationships. But just make sure that whatever you do, you stay consistent. So I'm going to do miles over gallon. So that means I'm going to start off my relationship by doing 29 over 15, because 29, I mean, I said 29, 290, excuse me, over 15. So that's 290 miles over 15 gallons. Then my next ratio, next rate, how far can you travel? So that's my unknown on 12 gallons of gas. So that's going to be X over 12, because I'm doing miles over gallon for that fraction as well. Once you have your setup, now you do what we did in the last problem, in which we cross multiply. Take the 12 up to the 290, 15 up to the X. $290 times 12 is 3480. 15 times X, of course, is 15X. Now divide both sides by 15. 15 is canceled on the right. 3480 divided by 15 is 232. And so that means you can travel 232 miles on 12 gallons of gas.
I have a question.
Yep.
I mean, I got 231.96. So we're supposed to round.
Did you do 3480 divided by 15, or did you?
I did. I don't know. I feel like the way you did it is a little complicated for me. So I just divided 200. I mean, I divided the first numbers that we were given. I can't see your screen anymore, so I can't see the numbers. So
let me go. You
what was
talking
it?
about?
Oh, I divided 290 by 15, and then I got 13 point. I got that answer, and then I times the 13 times 12, multiplied it, 13 point whatever times 12, and then I got 231.96.
Right. Okay. So now this way will ensure that you get the accurate, like the most accurate answer. Now that 290 divided by 15, was that a run-on decimal?
Yes, I believe so.
Yeah.
290 divided by 15. It was 19.333333.
Yeah. So that's where that happened. See, I didn't divide 290 by 15. I mean, yeah, by 15. And so that run-on decimal wasn't created, because what ended up happening is at some point you had to cut off that run-on decimal so you can complete your calculation. And so whenever you have to round or truncate an answer, you may not get as close to the exact answer as possible. So if you leave it at 290 over 15, that's the exact answer. And so when I multiplied it by 12, let's say if we leave it, like do it the way you did it. 290 over 15 multiplied by 12. I guess I could just show you. And if we multiply it by 12, that gives me an element. Let's do this. All right. So 290 is going to be 5 times 58. 15 is 3 times 5. And then 12 is 3 times 4. So now that I multiplied it by 12, that 3 is going to cancel out. That couldn't divide into the 290, because that's why you got to run on decimal. 3 doesn't divide evenly into 290, because that 5 did, but the 3 didn't. And that's where you got to run on decimal. When I multiplied it by 12, that got rid of that. So that's just like the background as to what's going on. So it's best if you have a run on decimal. It's okay to do it with the way you did it, but just know if you have a run on decimal, it's possible that when you complete the calculation, that run on decimal would be removed. So this way would actually give that process and opportunity to occur. You see what I mean? Um, this process wouldn't occur if you divide that 290 by 15 before you multiply by 12. So, um, like I said, doing it this way will ensure that if you're going to get the exact answer or the exact answer as possible, that you will get that. Just note if you get a run on decimal, if you have to round it off, you're going to get close to the answer, but you might not get the exact answer. And so that's where that may come to play. Um, hope that helped as far as what your question was. But if you didn't, but you didn't have to round off, because if you did it this way, everything would have worked out and just given you the 232. All right. Any other questions before we look at? I think it's it. Yep. Before we look at this last one, unless you guys want another one. All right. We have the dosage for a certain medication is 2 ounces for every 50 pounds of body weight. How many ounces of this medication are required for a person who weighs 175 pounds? All right. So just like before, you want to be consistent in your proportion setup. I decided to do ounces over pounds, so you keep that consistency throughout your relationship. Um, we have 2 ounces for every 50 pounds, so that's 2 over 50. Then it says how many ounces, which is X, are required for a person who weighs 175 pounds. So it's X over 175. All right, questions on the setup? All right, so then from there, cross multiply 175 times 2, 50 times X. So 2 times 175 is 350. 50X is on the right, so you divide both sides by 50. X will be equal to 7. So that means for a 175-pound person, they would need 7 ounces of this medication.
I'm sorry. I have one more question.
Yep.
So I don't know. I'm trying to understand. So we do it like this to get the more accurate answer, because I just divided 175 by 50 and got 3.5, and then seeing how many times 2 goes into 3.5. But I'm trying to learn how to do it like this, because to me, this seems more complicated than the way
Well,
I do it.
going back to what the difference between this one and the last one is that this one, like you mentioned, had a decimal that ended 3.5. So everything's all good. You multiply that times 2, you're going to get 7. But remember, the last scenario that we had a run-on decimal of 0.3 to infinity. There's no way for you to represent that. Now, if you can leave that in your calculator before you do your multiplication, then you will get an exact answer. But if you have to truncate that at any point, if you have to do, let's say if it was 1.33333, if you have to do 1.3, or let's say if you try to be more exact and do 1.333, no matter what you do, that is not 1.3 to infinity. So when you multiply this number times 2 or times 5 or whatever, you're going to get close. You're going to get close to your final answer, but you still won't get that actual exact answer because
So
of
would you
this.
not just write it in significant figures, like what 1.3? Okay, so basically we do it the way that you're teaching us so that we could get the most accurate answer.
Yes. Now, like I said, you can Let's go back to the one that we were talking about. I got to get those numbers. That was 290, 15. So basically, it's 290 over 15. When you divide that out, uh, 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 290 divided by 15, we get 19.3 repeated. All right. So now, if I don't leave it, if you leave it in the calculator like that, so you're not moving from this screen and just multiply it times 12, you will get your 232. But if you do anything different, if you do 19.3 times 12, you're going to get 231.6. If you do 19.333, you get 231.996. See, if you cut off that run-on decimal at any point, when you multiply it times another number, you're not going to get, well, let's say we multiply it times 12, you're not going to get the exact number of 232. You're going to get something close. You see what I mean?
Yes.
So if you have a run-on decimal, like I said, your process is not incorrect. But if you have a run-on decimal and you don't have a calculator that will allow you to keep that run-on decimal, let's say if you have other operations that you need to apply, I'm just talking about even moving past this moment, you just have to make sure that you either keep it as a fraction. We had 290 over 15. You can keep it as a fraction and then multiply it times the 12, or you have to the integrity, keep the integrity of your infinite decimal. If you keep the integrity of your infinite decimal, multiply it times whatever number you want to multiply, you still will get the exact answer. The problem comes in is when you decide to cut it off or you decide to round it. You're going to get something close, but not the exact answer. All right. So does that make sense? Does that help?
Yes, it helped. I just did it in my calculator and left the 19 with
Gotcha.
the, okay.
Gotcha. So yeah, like I said, your process, if you want to use that process, that's fine. You still should get the same answers. Just that, the only problem comes in when you try to round a decimal before you do your calculations. All right. Anything else? Anybody else on anything? This is the foundation of, ratio, rates, and proportions. So make sure, you get into your homework. Some questions may not come up. Like I try to emphasize, some questions may not come up until you actually start doing your homework. And let's see, somebody's in the chat. Could we do one from the worksheet? These look kind of hard. Let's see what we got going on here. And you said worksheet. I think you're talking about the homework. So ratio A to B. They give you A, they give you B. You guys can see the my math lab homework right screen. Making sure you guys can see it. So give you ratio A to B. Compare the following. Write it in two ways. So they give you that would be 210 over 520, and they want you to reduce the fraction. Where's my note? Matter of fact, let's just do it like this. So they give you 210 is equal to A, B is equal to 520. If you want to know A to B, then that's 210 over 520. And then I think then they ask you of B to A. That means you flip it and write 520 over 210. But they want you to reduce it so these zeros in the back will cancel. leaving you with 21 over 52. And anything in common with these two? Does it look like it goes into, no, so that should be a more simplified fraction. Here, that'll be 52 over 21. Oh, then it also says A is what percent of B. So you would just actually divide that 21 over 52. This is A over B. So you just do 21 divided by 52. That is, let me see how many decimal places they want. Okay. So this is round to one decimal place. So this is 0.404. And the reason why I do 3 here is because when you convert it to a percent, move it 2 to the right. So that should be 40.4%. Next couple of them still saying right as a fraction, lowest terms. 21, 2. Okay, so this one is a good one. 3, 2, 3 3/5. So like I said, some questions may not come up until you actually get in there, but the first few of them pretty much straightforward, asking you to set up your fraction according to the relationship of 2. Now here we have 3 to 3 3/5. That divisional bar is your 2. And I want to convert to improper fraction. So that'd be 3, your whole number, times your denominator, plus your numerator. So 3 times 5 plus 3. 3 times 5 is 15, plus 3 is 18 over 5. So that's 3 over 18 over 5. So that divisional bar and that divisional sign is the same. So I'm just writing it, whether you write it like this or not, if you're good with fractions, then that's great. Just making sure that everybody sees what I'm doing. So don't forget, whenever you're dividing by a fraction, you're going to multiply by the reciprocal. So you're going to flip that fraction that follows the divisional sign, change division to multiplication. And then they want you to write the fraction in lowest terms. So I recognize that there's a 3 and 18. Threes cancel. And that's 5 over 6. So that will be your answer in simplest form. So if you haven't done fractions in a while, you see that they didn't spend time talking about fractions, but they expect you to know that coming into this class. So, get with me, get with the tutoring or whatever if you need a refresher on fractions. I have other classes that I've made videos for fraction work, and maybe you just need a refresher. So, or if we need to sit down and talk about any of it, just let me know. But yeah, notice they didn't spend time talking about that because they expect you to know your fraction work and all the stuff as subtracting, multiplying, dividing fractions. So, like I said, it's not if you forgot stuff because you haven't used it in a while or whatever, not a problem. Just make sure you get with me. Don't stay in the dark if you don't have to. All right. Yep, no problem, no problem. Shorter side to longer side. Yeah, so a lot of these is just going to be establishing that relationship, especially using two. And just remember that whatever comes before the word two is your top number. Whatever comes after the word two is your back number or your bottom number. If you get in there, see something that you want to see me do, feel free to remind me next class or whatever the case may be, or shoot me an email and all that good stuff like that. So, questions, concerns, comments before we close out today. All right. Okay. So, try the stuff out. If you need to set up a Zoom session, let me know. Don't forget, like I said, Mr. Davis and the tutoring center, they're open as well. And we will go from there.
Should we email
Mhm.
you to set up the Zoom session?
Yes, yes. Email me if you want to do anything with me individually. And yep, or like I said, Mr. Davis email, I sent that as well. So you want to set up something with me or Mr. Davis, email would be the best way to go. Because I promise you I won't remember if you were to say it right now, you know what I mean? Because I just got so many different classes and moving parts and different students. So yes, starting that dialogue through email would be the best way to move forward. All right, anything else, anybody else? All right, you guys have a good one. Have a great weekend. Be safe. And I will see you guys on Monday.
Hey, you too.
All right, man. Take care.
All right.
All right, you have a good one. All right, y'all
Everybody
do the
take
same.
care.
Yep, you do the same.